Okay, in this lesson we're going to talk about precipitation reactions. Precipitation is when a solid, what we call a precipitate, forms as a result of two aqueous solutions reacting. Spectator ions are the ions which are not involved in forming the solid, also known as the precipitate. Okay. The net ionic reaction is a reaction about which is really occurring, which is the solid formation. And so we need to learn how to know whether or not a compound will precipitate. And so in order to do that, we have to know how to interpret solubility rules. So your solubility rules are in your reference packet, and on the right hand side of the screen you'll see I have them. They're kind of hard to read here, but if you take out your reference packet you'll be able to see them more clearly. And so first thing we're going to do is look at some examples of compounds and make sure we understand how to read our solubility rules. So KBR. So rule 1 says that all nitrates, acetates, ammonium, and group 1A salts, so that salt is just an ionic compound. So what that means is any compound made with a group 1 metal will be soluble. And so since potassium is in group 1, it is soluble. Potassium bromide is soluble. And so then we have lead 2 carbonate. And so we find a rule for carbonates over here. It's under the insoluble side. So all carbonates and phosphates are insoluble except those with group 1 and ammonium. Well, lead is not in group 1, and so that makes this compound insoluble, which would make it precipitate if it were to form in the reaction. Next we have zinc hydroxide. Again, we find the rule for hydroxides. All hydroxides are insoluble except those in group 1. Well, zinc's not in group 1. But also we have strontium, barium, and ammonium. So none of those are zinc. And so this one too would be insoluble and would precipitate in the reaction. So then we have sodium acetate. Over here we find in this first rule all nitrates and acetates. So all compounds with acetate are soluble. So it doesn't matter what it's with. If it's acetate, it's going to be soluble. Okay. Next we have silver iodide. So let's find the rule for iodide. That's down here in the second rule. All chlorides, bromides, and iodides are soluble except silver, which means silver iodide is insoluble. And then we have cadmium 2 sulfide. So let's find our rule for sulfides. Over here, sulfides. All sulfides are insoluble except goes in group 1 and group 2 and ammonium. Well, cadmium is not in group 1 or 2. It's a transition metal. And so this would mean it is insoluble and would indeed precipitate in the reaction. So let's apply these rules to chemical reactions. Okay, so precipitation reactions are just double replacement reactions. Okay, they're double replacement reactions. If no reaction occurs, you would write no reaction. And we know that no reaction would occur if all products are soluble. Okay, so first we have to determine what the products are of the reaction. And so we have to write balanced reactions for these. Okay. Okay, so if I can get all this on the screen. There we go. So for the next one. Alright, so we have iron 3 chloride. So let's write that. That means irons plus 3, chlorides minus 1. So I'm going to need 3 chlorides to make that add up to 0. So we have FeCl3. And sodium hydroxide. Sodium's a plus 1, and hydroxide's a -1, so we just need one of each. This is a double replacement reaction, as we said, so iron then, which was +3 before, is going to stay +3 when it combines with hydroxide, and since hydroxide's a -1, we'll need 3 of those. Plus, sodium and chlorine will combine. Sodium's a +1, chloride's a -1, so just one of each. We do still have to balance it, and so we have 1 iron, 3 chlorides, 1 chloride, multiply this by 3. That makes 3 sodiums, we multiply by 3. That makes 3 hydroxides, well, we have 3. So now we're balanced. So next, we have to determine which of these is our solid product. Alright, so we go back to our solubility rules. So iron 3 hydroxide. So we come over here and we find our rule for hydroxides. All hydroxides are insoluble except for group 1, strontium, barium, and ammonium. Well, iron is not any of those. And so that would mean that iron is going to be our precipitate. So it's going to be a solid. And we write the letter S next to it. Okay? Now, sodium chloride, sodium's group 1, and all group 1 compounds are soluble. And so if it's soluble, we write an AQ next to it. Okay? AQ stands for aqueous. Alright, so next let's write our net ionic equation. Our net ionic equation is what's really occurring. So it's the ions which form the solid. So I kind of do those backwards. So I start with the solid product, which is iron hydroxide, and then we write the ions that formed that. So we had an iron plus 3 ions, and then we had 3 hydroxide ions. And ions only form when they're dissolved, substances are dissolved in water, and so they always have an AQ next to them. Okay, and so that's our net ionic equation, the 2 ions which form a solid product. Okay, the spectator ions are the ions, if you recall, which did not participate in forming the product. So what were those? Sodium and chlorine. So the spectator ions were sodium and the chloride ion. And our precipitate, again, was the iron 3 hydroxide. Okay, let's look at another example. Magnesium sulfate and potassium phosphate. Alright, so magnesium plus 2, sulfate minus 2, so that adds to 0. So we just need 1 of each ion, MgSO4, plus potassium, group 1, plus 1, phosphate, minus 3. So I'm going to need 3 potassiums to make that 0. So this will be K3PO4. Since it's double replacement, my metals need new partners, so magnesium is going to combine with phosphate. And since magnesium was a 2 and phosphate's a minus 3, we're going to need 3 magnesiums and 2 phosphates. And then potassium sulfate, right? And since potassium was a plus 1 and sulfate was a minus 2, I need 2 potassium. So K2SO4. Now we use our solubility rules. So our first one's phosphate. Find a rule for phosphate here. All carbonates and phosphates except group 1 are insoluble. Well, is magnesium in group 1? No, it is not. And so that's going to be our solid precipitate. So we'll write that in here. Magnesium phosphate is our precipitate. That means that our potassium sulfate is our compound that's dissolved, and those make up our spectator ions. So potassium and sulfate are our spectator ions. So let's write our net ionic equation. Again, starting with our solid precipitate, Mg3PO4, 2 is our solid. And so this breaks apart into it. So we break this apart into its ions that formed it. So we have 3 magnesium ions, which are plus 2, and we had 2 phosphate ions, which were -3. And since they're ions, they only exist when they're dissolved in water, and so they have to have AQ written next to them. And that's our net ionic equation. Okay, one more together, and then I'll let you do one. So then we have copper 2 nitrate and calcium hydroxide. Copper 2, that means copper is +2, nitrate's -1, so we need 2 nitrates. So that would be CuNO3, 2, plus calcium, which is in group 2, so that's +2, and hydroxide's a -1. We'll need 2 hydroxides to make those add to 0, and so we get Ca in parentheses OH2. Again, double replacement, so copper is going to combine with hydroxide, and since copper was +2, hydroxide was -1, we're going to need 2 hydroxides, and then calcium nitrate. Calcium's +2, nitrate's -1, so we'll need 2 nitrates. And so we balance 1 copper, 2 nitrates, 2 nitrates, 1 calcium, 2 hydroxides, 2 hydroxides. So that's all balanced. Then we have our net ionic equation. First we should determine our precipitate. So if we look at our rules again, we have hydroxide, so all hydroxides are insoluble except group 1. Is copper in group 1? No, it is not. And then also strontium and barium, those are not copper either. So copper 2 hydroxide is going to be our precipitate, which means calcium nitrate is going to be dissolved completely, and our spectator ions will be the calcium ion and the nitrate ion. To write our net ionic equation, we have our solid product, and then on the reactant side we have the 2 ions that make that up. So copper was +2, plus 2 hydroxide ions, which are -1, and ions only exist when they're dissolved in water, and so they have AQ after them. And I just realized that we didn't balance the reaction up here, so let's take a moment and balance that. 1 magnesium, 3 magnesium. So we multiply this by 3. That makes 3 sulfates. Over here we only have 1 sulfate, so we multiply that by 3. So now we have 6 potassium. Over here we need 6. We already have 3, so we just multiply by 2. That makes 6. And that gives us 2 phosphates, which we have. Okay? So next I want you to try the next one. Go ahead and pause the video, and then when you're done, play again, and I'll explain it. So, sodium, group 1 is +1, chromate -2, so we'll need 2 sodium ions to make that add to 0, and so we would have Na2CrO4, and then we have strontium, which is +2, and nitrate, which is -1. So +2 and -1 does not equal 0, so I need to multiply nitrates by 2. And so we'll have 2 nitrates. There's strontium, nitrate, SrNO3, 2. Double replacement reaction. So sodium is going to combine with nitrate. Sodium and nitrate are both 1s, so 1 of each. And then strontium, which is a +2, and chromate, which is a -2. Again, 1 of each, since they already add to 0. Right, we balance 2 sodiums, 1 sodium, so multiply by 2. That gives us 2 nitrates. We have 2 nitrates, so that's good. And then we have 1 strontium, 1 strontium, 1 chromate, 1 chromate, so we're all balanced. So we look at our solubility rules. Sodium nitrate, all nitrates are soluble, so